Hi everybody, these are Unit 12, Notes number 1. This is our final unit for algebra. It only consists of 2 sections of notes. It's all about simplifying radicals, meaning square roots. Now we've already dealt with square roots in our problems in Unit 11. For most of them we had perfect squares, no problem. Some of them we did not have perfect squares, but we were okay with you giving us a decimal. Well, if you really say you're simplifying radicals, it means that you actually leave it in what we call simplified radical form, which will consist of no decimals. And that's what we'll be focusing on in these 2 sections of notes. Now there's a few things though that we want to review first before we just go right into the problems, okay? So make sure that if you're not familiar with these things, that you definitely make sure you listen, write down the examples, and take any extra notes that you need to. So the first thing we want you to make sure that you know is how to do prime factorization. So prime factorization is finding the prime numbers that multiply together to make an original number. Now just so we're clear guys, prime numbers, well there's a ton of them, but your more common ones are 2, 3, 5, 7, 11, 13, yada yada yada. They are numbers that only are divisible by themselves and 1. So when we prime factor a number, we're looking to get a big mess of those being multiplied together. So we're going to start with the number 40. Now our whole goal is to get prime numbers. So yes, I'm sure we can think of a ton of different numbers that multiply to give us 40, but let's just start with primes. In fact, let's start with that smallest prime possible. If you have an even number and you want to prime factor it, go ahead and divide it by 2 first. Use a calculator if you'd like. But when we divide it by 2, we'll get 20. So at this point, we're at 2 times 20. So now 2 is definitely a prime, and I'm just going to carry it down to make sure I don't lose it at the end. But now let's go ahead and break up the 20. Again, I'm going to use the same thing I did with the original number. Let's divide it by 2. So that's going to give me 2 times 10. Now I'm going to pull down that first 2, pull down that second 2 because I don't want to lose them in the end. And now let's do the 10. Well, when I divide 10 by 2, I get a 2 and a 5. Now I know I can stop because 5 is a prime number. If you didn't know that it was a prime number, well, go ahead and try dividing it by 2. You'll get a decimal. Divide it by 3, you'll get a decimal. And hopefully by then you'll stop and go, oh, 5. Okay? So right here, guys, that is what we call the prime factorization of 40. Now this strategy we're recommending because what we're going to end up doing with these problems is looking to see pairs of factors that are the same. So by doing our method this way, we've got all those 2's clumped together, and it's easier for us to see if we've got a pair of those 2's, which you see we do right here, okay? So let's go ahead and just practice one more with 63. Now notice that 63 is not divisible by 2. However, if I grab my calculator, please feel free to use a calculator. Okay, you'll do 63 divided by 3, you'll get 21. So we'll start with 3 times 21. Again, just like before, I always recommend carrying down those prime numbers that you just did because you don't want to lose them at the end. Now we go to 21. Again, it is not even, so it can't be divisible by 2, but when we go ahead and try 3, we get 7. So that is 3 times 7. Now we take a look at the 7. 7 is prime, so we are finished at this point. Just like the 40 up here, these are all prime numbers. So 63, his prime factorization is 3 times 3 times 7. And again, it's just nice kind of writing it out in this way because you notice that there's 2 3's here. And that's what we're going to talk about with our next little tip. So moving on, we mentioned that we were square rooting numbers here. Well, let's make sure that we're clear on actually what's happening when we square root. I feel like what happens is we make you guys memorize a list of perfect squares so that you know that the square root of 25 is 5. But are you clear on why it's 5 and what's that process? So let's just take a look at some pretty little perfect squares here so we're clear as far as what's happening. When you are square rooting, you are looking for 2 of a factor. You're looking for a pair. When you have 2 of a factor, then you can move that factor out of the radical. So when we look at the 4, we know that if we prime factor the 4, that gives us 2 and 2. So if I just go ahead and rewrite that underneath that radical, this is really what the square root of 4 is saying. Well, referring back up to this tip here, guys, if I have 2 of that common factor, well, that means that 1 bumps right on out. And then these just completely disappear. So the idea is that when you have 2 of a factor, 1 of them pops out, and then you no longer have those numbers underneath the radical anymore. So this is why the square root of 4 is simply 2. And if we move down and kind of do the same thing for the number 9, when I prime factor, I get 3 times 3. Well, let's rewrite that underneath the square root. So again, you've got 2 3s. You've got a pair of 3s. Well, since there's 2 of them, you can bump out that factor of 3 and cross these out underneath. Because there's nothing left underneath and you pulled out that 3, the answer is 3. And this thought bubble here is pretty much just stating that since 4 and 9 are perfect squares, yeah, you're not going to have any numbers left behind. And that's why when we say, what's the square root of 9 or what's the square root of 49, you can just give us a number and you no longer have that square root sign. What's going to happen with the problems in this section is now you will have something left over, okay? And that's the last thing we want to talk about before we delve into all of our problems. So basically, guys, if there is not enough of a factor to make a group of 2, then that factor has to stay underneath the radical. He cannot come out. And that's what happens when you try to square root numbers that are not perfect squares. So what I did with this 18 is I actually prime factored it so I could really see what it had. Okay, so just so we're clear, over here, I prime factored. So this is the prime factorization. I got 2 times 3 times 3. Now, like the ones up top that were perfect squares, well, hey, look at this. I have 2 3s. I have a pair of 3s. So what happens is that means a 3 pops right on outside the radical and just goes right to the front, and therefore no 3s left underneath. However, notice this 2, he didn't have a partner. He doesn't have a pair. He's just by himself. So unfortunately, what that means for that 2 is he's gonna have to stay underneath. So to actually simplify or write the square root of 18 in what we call simplified radical form, we would have to write it as this. You would say 3 times the square root of 2, or you can say 3 radical 2. So that's going to be the whole point of our problems, guys. We're going to prime factor the number that's underneath the square root. We're going to look for pairs. We're going to pull the guys out who are part of a pair. Somebody who's not part of a pair, he's going to stay underneath. So let's take a look. So what we did for the first 3 examples, just so we could follow along with these steps, is I wrote down the steps on the left side, and then we've got these 3 examples on the right, okay? So a good idea would be at this point to write down these steps, okay, to make sure that you're clear as far as what we need you to do when we simplify radicals. Starting with the top, okay, and starting with our first step. The first thing we want to do is we want to prime factor. We're going to find the prime factorization of the number under the radical. So that would be the 8. So use a calculator if you need to, but 8 divided by 2, yeah, we get a 4. bring down the 2, and then break down the 4, we get another 2 and 2. So the prime factorization of 8 is 2 times 2 times 2. So what we're going to do is we're going to go ahead and write that prime factorization underneath there, just so we're clear on what we've got going on. So all of this is with that first check mark. That's the first thing you want to make sure that you do. From here, we're going to now look for those pairs. So what we want to do now is move one of each pair of factors to the outside of the radical. So if you notice, there are 2 2's right here. I know there's that third 2 there, but I'm sorry, he can't play, okay? So it's only 2, a pair. So since these are a pair and they're both 2's, I'm gonna pull that 2 and he's gonna come out in front. Now this is important here, guys. Once you pull out that factor who was part of the pair, make sure you cross these out underneath here. They no longer exist. Think about the square root of 4. You wouldn't still keep a 2 underneath the square root, okay? And then at this point, anybody who was not part of the pair, remember we had said just stays where he is. So at this point, our final answer is the 2 from the outside here, and then the square root, and then this 2, well, he just kind of stayed inside. So this would be our final answer. So that step there is basically saying, guys, go ahead and move out the people who are part of the pair, but unfortunately keep the ones who are not part of the pair inside the radical, okay? And then lastly, you do see this check mark here. It does say, if needed, simplify the expression by multiplying numbers outside the radical and numbers remaining inside. For this example, we didn't need that step. We had that one pair, we bumped him out, we kept that 2 that was left over underneath. However, when you take a look at this second one, you will see that we will have to do some extra simplification. So first things first, guys, again, going back up to our kind of check mark steps here, we definitely want to prime factor the number first. So when I look at 54, I know that it's even, so the first thing I'm going to do, and again, I'm just going to grab my handy dandy calculator to make sure I'm doing it right. I'm going to take that 54, I'm going to divide it by 2. And that's going to give me 2 times 27. So now I know I've got that first 2 for sure in that prime factorization. Now 27 though, of course, is even, so I'm not going to be able to break him down with a 2. Well, let's go ahead and divide him by a 3. And that's going to give me a 9. And now notice a 9 can break down further. So the 9 is going to go down. Let me just carry these down so I don't forget about them. This 9 will carry down to another 3 times 3. So the prime factorization, what's actually really happening underneath this square root is 2 times 3 times 3 times 3. Now comes this step right here in green. Move one of each pair of factors to the outside of the radical and then cross them out. So right here, guys, I notice I've got, again, a pair. I've got 2 3's. So one of them will go ahead and come outside, and then I'm just going to be able to cross these out because I took care of them. So right now, notice I have, and I'll just rewrite this down the bottom here. Right now, I've got a 3 on the outside, but I still have a 2 times 3 on the inside. And this is where this final step is coming into play. Sometimes what's going to happen is you're going to have more than just one leftover person. Sometimes you'll have 2. And if that's the case, then you're just going to go ahead and multiply them. So the important thing here is you can only multiply numbers that are either both on the outside or both on the inside. So this 3, we can't touch it. He's outside. But I will be able to multiply the 2 and the 3, and that will give me 6. Now they're still going to be underneath the square root bar, but at least they found each other. It's a nice little happy ending. So the 3 got out because he was part of a pair. The remaining 2 and 3, well, we just go ahead and multiply those, and that becomes our new radicand. That's what we call the number under the square root. So the square root of 54 in simplified radical form is 3 radical 6. We're just going to go through one more, referring to our notes, and then I've just got a few more just for some extra practice. So this time we've got 160. Definitely a much bigger number, but that is why we use our prime factorization. Okay, noticing that it's even, I'm thinking I'm just going to divide it by 2 again. 160 divide by 2, and I get 80. All right, from there, let me bring this guy down so I don't forget him. Divide the 80 by 2, and I get the 2 and the 40. Again, bring down these so I don't forget them. 40 is 2 and 20. Whew. Bring down all of these 2's so we don't forget them. Break down the 20 into 2 and 10. And then lastly, whew, this is a big one. Bring down the 2, bring down this 2, bring down this 2, bring down this 2, and now finally the 10 breaks up into 2 and 5. So, the prime factorization of 60 is going to be 2 times 2 times 2 times 2 times 2. Is that all of them? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, and a 5 there. Whew. All right, so in this case, notice guys, we're gonna have more than just one pair, and that's okay, all right? So what's gonna happen here is we've got this first pair here, so that 2 will come outside. I'm just gonna cross those out. We'll have this pair here, so that means that 2 is going to come outside. These will cross out. So now basically what we have going on here is we have 2 times 2 in the front. That's coming from that green 2 and that red 2. And underneath here we've got 2 times 5. So any numbers that end up getting pulled out, if there's multiple numbers, they're going to end up getting multiplied. So just like we multiplied underneath the radical for this one here, we're going to do the same thing here. The 2 and the 10 will become 5. And then we're going to go ahead and multiply the 2 that came from the outside, and that will give us 4. And that will be our final answer, 4 radical 10. So overall, guys, again, what we're stressing with this method, and there are lots of ways to simplify these, and you may even kind of discover a way as you watch these, and that's okay. But basically, our method is saying, let's go ahead and prime factor, so I can look at all those primes. And then I'm just going to start pairing them up. If somebody can pair up, then that means that number gets ousted out. Every pair pulls one of them out. And then anybody left over, we can just multiply. And because we prime factored this, even though we're multiplying to get a bigger number like 10, we already know this is as low as it can go. We're not going to get any other pairs out of him because we already know he was a product of prime. So that's the basis of this method. So let's go ahead and just do a few more examples, and then we'll get you on the homework to practice on your own. So number 4, we've got the square root of 27. So just like we talked about before, we're going to go ahead and prime factor that first. Of course, 27 is not even. He is odd. That'll end up giving us 3 times 9. The 9 will break down to 3 times 3. So what we have going on here is a 3 times 3 times 3. Now it's time to look for our pairs. Notice that we've got a pair of 3's right here, so therefore a 3 will come outside. These will disappear. However, this 3, nope, doesn't have a partner, so he's going to stay inside. So our answer here will be the 3 on the outside, which came from the pair, and then a 3 on the inside because he was not part of a pair. So the simplified radical form of the square root of 27 is 3 radical 3. Moving on to 80. Again, let's go ahead and prime factor first. 80 is 2 times 40. I feel like we've done 40 many times. 40 is 2 times 20. Again, the 20 is 2 times 10. And then we've got the 10, which is 2 times 5. So 80 is going to break us down into 2 times 2 times 2 times 2, and then times 5. So underneath this square root, we will have 2 times 2 times 2 times 2 times 5. Let's go ahead and look for our pairs. Notice we've got one pair of 2's here. That's going to go ahead and pop out. But then we also have this pair of 2's here. So another 2 will go ahead and come out. However, underneath we will still have that 5. So in the end, our answer will be 2 times 2 in front of the square root, 5 underneath. When we do 2 times 2, that's going to give us 4. And our answer will be 4 radical 5. Now notice for 6 and 7, I've actually put a coefficient in front of the square root. And that's just to help prepare us for something that we're going to do in our second section of notes. But basically, guys, like I said, this is a coefficient. So this is no more than just a number on the outside, just waiting to be multiplied to anything that comes out at the end. So right now I'm going to ignore it as I prime factor, and I'll just take care of it at the very end when I start pulling stuff out. So 24 gives us 2 times 12. Bring down the 2. The 12, again, 2, and then times 6. Bring down the 2, 2, and then the 6 is 2 times 3. So we've got 2 times 2 times 2, and then a 3. I'm just going to rewrite that underneath here with that 5 in front, just so we're clear. We've got 2 times 2 times 2 times 3. Let's go ahead and look for our pairs. So we've got one pair of 2's here, so that means a 2 is going to come over to the outside. These will end up getting crossed out. Of course, what's left underneath there is just a 2 and a times 3. So I'm just going to rewrite this so we're clear as far as what we have. Sorry for all the crazy colors. But what we've got going on here is we've got the 5 that was originally out here. We've got the 2 that got pulled out, and that, of course, will be multiplied. And then underneath, we've got the 2 times 3. So according to our last step, we want to multiply anything that's on the outside, multiply anything that's in the inside, and then that gives us our final answer, 10 radical 6, or 10 times the square root of 6. And lastly, the 63 should look familiar. We prime factored it in the beginning, okay? So just in case you forgot, and I'll put that over to the side here, 63 was not divisible by 2, so we did it by 3, and it gave us 3 and 21. Then the 21 gave us 3 times 7, and then that was all we had because they were all prime numbers. So what we've got going on is we've got that -4, which we're just going to hang on at the end like there for now. Underneath here, we'll have the 3 times 3 times 7. So the prime factorization is underneath. There are 2 3's here, so therefore one of them pops out, crossing these out. So what we have is in the front, we still have that -4. That was the coefficient from the original problem. And then we've got the times 3, and then underneath here, we've got the 7. So over here, we just have to do the -4 times 3 in front, and then we are done. So -4 times the square root of 63 ends up simplifying to -12 square root of 7. From here, guys, make sure that you let us know if you have any questions whatsoever, okay? Also, we'll have the homework on Google Classroom, so please make sure you go through that. It will give you your score right away. We'll also have notes on every single problem about little tips or what you should have remembered. Please take the time to read through those notes. Even if you want to screen capture them on your phone and then use those as your notes when you take our final quiz, that would be perfect as well. Okay, so good luck. I hope this helped, and we'll talk to you later. Bye-bye.